Welcome back. We're in Giancoli Ch2 Problem number 8. A horse canters away, he kind of trots away from its trainer in a straight line. Well, that's nice, it's going in one dimension there. Moving 130 meters away in 14.0 seconds. It then abruptly turns and gallops halfway back, so it goes faster halfway back in 4.8 seconds. You also know it goes faster because at 4.8 seconds, it goes half of that distance. Well, it would take, if it was going the same speed, it would take 7 seconds to go that, half of that distance there. Calculate A, its average speed, and B, its average velocity for the entire trip, using away from the trainer as the positive direction. All right, so you notice how we want to draw a picture here, because this can get a little bit complex if we don't understand what's actually going on. So we'll draw some trainer. Here's some person. And I'll label them trainer, and we'll give them a little cap, like old-timey cap. Yeah, he's having a good time. Okay, trainer there, and a horse. Oh no, you're gonna make me draw a horse. Oh, this usually doesn't go well, but we'll see. So, shunk, 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 shunk. You're drawing a horse too, and then going to compare it to mine and see if it looks any better. These are really thick legs, huh? A thick-legged horse. That's not so bad. Kind of looks like a dinosaur at this point. How do I make it look more like a horse? They're like more pointed. Ears. Yeah, I didn't go to art school. My wife did. Okay. There we go. I got to take more art lessons from her. Anyways, here's my horse. The point is that the horse goes away, and he goes over here. And let's go ahead and let's say that he is 0. And so the horse actually starts at 0. My picture, I guess, doesn't really show that. And then it goes 130 meters away over here. And then it stops and it turns around and it goes halfway back. So halfway is going to be 65 meters. So I have my position axis here is actually what I'm showing. And this way is the positive direction, as my numbers already show. And then the horse gets back to right here. Okay, cool. So maybe I'm kind of showing the direction that it's going with these little dotted arrows there. All right, how else can I represent that? I bet I could graph this too. Let's go graph this. I bet that'd be more descriptive for us. So let's go graph that. And we have a position axis right here. So let's go ahead and let's put the position axis, it usually goes on the vertical axis, and time on the horizontal axis. Why is that? Well, you'll see in just a second. I'll point it out. Well, he's going a constant speed as he canters away. Or at least we're going to assume he goes at a constant speed. We just know that he gets to 130 meters, actually. But we're going to put 130 meters there, and we'll put, say, 14 seconds is right here, 14.0. So I know he gets here. I'm going to assume that he does it at a constant speed, although we don't actually know that. Boop. So that's the cantering away. Then he turns around, and he goes backwards. Well, the trainer is here at 0, and so going backwards, we know he ends at the 65 there, so let's go put the 65 on here. So then he must get back down to this level. Now what time does it takes 4.8 seconds. Was he going to go 4.8 seconds? 4.8 seconds somewhere around here. 4.8 seconds back here? No. He's not going to go backwards in time. If you were timing this whole thing, it'd get to 14 seconds. It'd keep going. So 14 plus 14.8, we got 18.8. And so 18.8 is going to be something over here. And it gets back to 65 there. And now when we connect that, like that. Now, the way that I drew it, I probably should have emphasized this more. I look at this and I go, hey, I know from before that the slope of this, the slope of any position time graph, is my velocity. Check it out. It's in meters per second. Okay, cool. So now the slope of this first portion versus the slope of this second portion. I know he's going faster the second time around because he goes half of the distance, but he does it in even less than half of the original time. So this guy is steeper. than that guy over there. Now on my picture, maybe you can tell a little bit, but it's pretty hard because it's kind of a sketch here. But if we went and graphed it a little bit more accurately on graph paper, you'd be able to see that, yes, this one, the second portion is actually steeper than that first one. All right, now we got to calculate the average speed and its average velocity. So let's do speed, average speed. I know it's some sort of distance over some time here. Do I know these things? Well, I do know the distance. Is the distance 65 meters? No, we know it's not, because the horse goes from 0 to 130, and then he goes another 65 as well. So 130 plus 65, that's 195, if I can do math in my head, which sometimes I can. And he did that in 18.8 seconds. So he went some distance, did it in 18.8 seconds. I grabbed my calculator, 195 divided by 18.8. And my calculator just stopped working there, 18.8. And we get 10.37, 10.37. Notice I put the units in there, so it's meters per second, and that helps me out. And then we're going to do the average velocity as well. I'll do it right next to there. Maybe I'll pick another color because it'd be nice. Average velocity we know is the displacement, the change in position per some time there. Do I know the displacement? Well, he started at a position, x naught, was 0. And then he ended over here. And so I know its ending position, some later time, or final you might say, is 65 meters. So now we know that a change in position is just ending minus beginning, now per time there. And the ending was 65, the beginning was 0, and these are in meters. And we did that in 18.8 seconds. Cool, 65 minus 0 is just 65, so I got 65 over 18.8, and I get 3.46, 3.4, oh gosh, 46 meters per second, average velocity. And I guess I could write that in there. So it's implied that it is the same thing because it's in this vertical line there, but now just do that anyways. So then we go, hey, the average speed and the average velocity are different. Why? Well, they describe slightly different things. The average velocity, or velocity, is talking about, hey, how far did you ultimately go? Where did you end at versus where did you begin? I don't care what kind of zigzag pattern you went in. Where did you ultimately end up, and where did you begin? And how long did it take you? There's velocity. Speed and distance are both talking about, yeah, but what about the whole path? I bet it'd take you longer, or it'd be more efficient or more taxing. I bet it'd take you more energy to do this big zigzag pattern all along here over some time period here. Well, average speed is describing that, per time, that distance per time there. So describing two slightly different ideas there. Okay, great. That's it. Have a wonderful day. Bye.